Exponential and logarithmic equations. This is a summary of those properties that we had in our last video. You can pause here to refresh your memory if you like. Let's go ahead and try to solve this equation. We want to express the answer exactly and as a decimal approximation. So the first thing that we want to do is isolate the part that's raised to the variable. So we need to divide both sides by 3. E to the 5x is equal to 11/3. Now to get this variable out of the exponent, we can take the natural log of both sides. I chose natural log because we have a base e, and natural log of e is just 1. So this leaves us with 5x is equal to the natural log of 11/3. Divide both sides by by 5, and you get x is equal to the natural log of 11/3 divided by 5. So this would be your exact answer. If we wanted to approximate that, we just put it in the calculator. Natural log of 11/3 divided by 5. And we get approximately 0.26. We'll just leave it like that. Solve the equation e to the 8x plus e equals 8 to the ex plus 8. Express the answer exactly and as a decimal approximation. And we want to use this for e. So you can either type that in your calculator or you can use the e button that's on your calculator. So let's go ahead and take the natural log of both sides. If we take the natural log of this side, all we're left with is the exponent. So we'll have 8x plus e is equal to, and on this side we'll have ex plus 8 natural log of 8. That's what we'll have after we take the natural log and use the power rule. Okay, so now what we need to do is get all of our x's on the same side. So we're going to have 8x plus e, ex natural log of 8 plus 8 natural log of 8. Move this term over here and move the e to the right. So we'll have 8x minus ex natural log of 8 equals 8 natural log of 8 minus e. Now what we want to do is factor out those x's. We'll move this and work on it later. So factor out an x, we'll be left with 8 minus e natural log of 8 equals 8 natural log of 8 minus e. Divide both sides by this parentheses and you'll have x is equal to 8 natural log of 8 minus e all over 8 minus e natural log of 8. So this would be your exact answer. But what would the approximation be? This will be approximately 5.9. Log base 5 of x minus 1 plus log base 5 of x plus 4 equals log base 5 of x minus 5. Okay, let's use some properties of logarithms. So first of all, we have log base 5 of x minus 1 times x plus 4 is equal to log base 5 of x minus 5. We use the product rule on that one, if you remember the product rule. Now we have log base 5 on both sides, which means that the arguments must be equal. Let's go ahead and multiply this one out. We'll have x squared plus 4x minus 1x, so plus 3x minus 4 is equal to x minus 5. Now this is a quadratic equation, so we do need to set it equal to 0. We'll subtract x and we'll add 5. So x squared plus 2x, 3x minus x is 2x, and negative 4 plus 5 is positive 1. Now let's factor it. That would be x plus 1, x plus 1. That means x is equal to negative 1. Now let's check this and make sure it works. If you were to put in a negative 1 here, you will get negative 1 minus 1. Your argument is not allowed to be negative. That means this particular equation has no solution. How about this one? Natural log of x plus 2 plus natural log of x is equal to 0. Because this is addition and these bases are the same, we can combine these with multiplication. So we'll have natural log of x times x plus 2 is equal to 0. So natural log of x squared plus 2x is equal to 0. Now for this one, you can probably just switch it to your exponential form. Remember, this is log base e. So this means e to the 0 equals x squared plus 2x. E to the 0 is 1. So let's set this equal to 0. We'll have x squared plus 2x minus 1 equals 0. Well, now we're going to have to use the quadratic formula because this one won't factor. So we'll have negative b plus or minus the square root of b squared minus 4ac all over 2a. That's going to be 4, is that plus 4? All over 2. Okay, so we have negative 1 plus the square root of 2 and negative 1 minus the square root of 2. Plug both of these in your calculator and you'll find out that negative 1 minus the square root of 2 is a negative number. And if you put a negative number here, it won't work. So that means the only solution is x equals negative 1 plus the square root of 2. The magnitude of an earthquake is measured on the Richter scale as a logarithm of intensity of the shock wave. For magnitude r and intensity I, the formula is r equals log of I. The 1994 earthquake in Northridge measured 6.7 on the Richter scale. The Long Beach earthquake in 1993 measured 6.2 on the Richter scale. Compare the intensities of the two earthquakes. So let's see, we have Northridge and we have Long Beach. What do we have here? The earthquake in Northridge measured 6.7 on the Richter scale. So we have 6.7 is equal to the log of I. And for Long Beach, we have 6.2 equals the log of I. We can change both of these back to exponential form. This means 10 to the 6.7 equals I. And this one means 10 to the 6.2 equals I, or vice versa. Well, to compare these, you need to divide them. So the comparison. This is the comparison of Northridge to Long Beach. This will be 10 to the 6.7 divided by 10 to the 6.2. that's going to be 3.16. Now what exactly does that mean? That means that the earthquake in Northridge was 3.6 times as intense as the earthquake in Long Beach. A chemist running tests on an unknown sample from an illegal waste dump isolates 50 grams of what she suspects is a radioactive element. In order to help identify the element, she would like to know the half-life. She determines that after 40 days, only 40 grams of the original element remains. What is the half-life of this mystery element? Remember that our formula is A of t is equal to the original amount e to the RT. Well, we need to find out the rate at which this particular substance decays. So we know that after 50 grams was isolated, that was the original amount. 40 days later, only 44 grams were left. That's e to the R times t, which is 40 days. So divide both sides by 50. And now we need to take the natural log of both sides. So the natural log of 44/50 is equal to, remember the natural log of e is 1. So you just have 40r. So r is approximately, well, it's exactly the natural log of 44/50 over 40. But we do need to get an approximation. So we have the natural log of 44/50 divided by 40, and that gives us a negative number, negative 0.0031958343, and it keeps going on and on. What I'm going to do is store this in my letter A, I think. Remember I told you this before, on your calculator is a stow button, so I do stow and then push the alpha button and then push the math button, because math is the letter A. So I'm going to store that in alpha A. So now that I have that rate, I need to know what the half-life is. Well, half-life is how long it takes for 1 gram to decay to half a gram. So if we start with 1 gram, that's going to be the original amount. And if we end up with half a gram, that is how much time, that is how much is left after that much time is passed. So that time was what we're actually looking for, the half-life. So we have another part to this problem. 0.5 is equal to 1, that's the original amount, times e to the r. This is my r, so I'm going to put it in as a because that's how I stored it in my calculator, times t. So 0.5 equals e to the at. We need to take the natural log of both sides. So the natural log of 0.5 is equal to, natural log of e is 1, so we just get at, which means t is equal to the natural log of 0.5 divided by a, which is approximately natural log of 0.5 divided by alpha a, 216.9. So approximately 217 days is the half-life of this particular substance.